Hi, mathletes. Today we're going to look at box and whisker plots. And a box and whisker plot is sometimes called a box plot. It's a special kind of graph and it shows how spread out a bunch of numbers are, like temperatures, test scores, or maybe how many hours people sleep. It helps you quickly see what's typical, what's high or what's low, and which numbers are really different. We call those numbers outliers. Imagine that you're collecting temperatures from 10 cities in March. Some are cold and some are warm. Instead of listing all of them, you could draw a box and whisker plot to show the full picture in just one neat line. And actually, stay with me in this video because we're going to do it in just a little bit. So, box and whisker plots show five main things. Here's an example of one. That purple dot shows the lower extreme or the minimum. It's the smallest number in your set of data, except for the outliers. The lower quartile, or quartile 1, is the number that is 25% of the data is below. It's the start of your box, and in this case, it's our red dot. That blue dot is my median. That's the middle number. And notice that it has the line inside the box. The upper quartile, or quartile 3, is the number that 75% of the data is below. That's the end of the box. In this case, my green dot. And lastly is my purple or my pink dot, and that's my upper extreme or my maximum. It's the largest number in my set of data, again, except for the outliers. Now that box, well, it shows where the middle 50% of the data is. And the whiskers, well, they stretch out to the lowest and the highest values, again, as long as they aren't outliers. So why are box and whisker plots helpful? Well, it's a quick way to see how the data is spread out. It's easy to spot if something is really different. And it's great for comparing lots of data sets side by side. So the first step in constructing a box and whisker plot is to arrange the data from least to greatest. Then you need to find the following: the median, the lower quartile or quartile 1, the upper quartile or quartile 3, the lower extreme, which is the minimum, and the upper extreme, which is the maximum. So let's try this example. The following set of numbers are the amount of marbles owned by 15 different students. To save on time, I already arranged them from least to greatest. First, we're going to find the median. So the median is the value that is exactly in the middle of an ordered set of numbers. So you'll notice here that I have my set of numbers and I ordered them again from least to greatest. And I noticed that the number 68 is in the middle. There's 7 numbers to the left and 7 numbers to the right. So 68 would be called my median. If you're finding the median in an ordered set with an even number of values, you have to find the mean of the two middle numbers. Let me show you what I mean. For example, let's say that your data set is small. It's just 3, 5, 7, and 10. Well, notice that your middle numbers are 5 and 7. So you have to add those together, which is 12, and then divide by 2. So your median is actually 6. Now let's look at these. We have our 68 as our median, and now we're going to look at the values to the left of the median, not including the median. So I highlighted them for you. Again, notice the median is not highlighted. Now we're going to find the median of this set of numbers. In other words, the middle number. And the middle number for this one is number 52. Again, there's 3 numbers to the left and 3 numbers to the right. So 52 is what we would call our lower quartile or quartile 1. Now we're going to do the same thing, but this time we're going to look to the right of the median. We're going to find the middle number there, which is 87. So 87 is what we call our upper quartile, quartile 3. The last part is to find the extremes. So let's find the lower extreme first, and that's the number that's the lowest value in our data. So that's going to be number 18. For the upper extreme, it's the highest value, and that's going to be 100. So now we have our 5 circles, and we can take these circles and use them as dots in our box and whisker plot. The first thing we need to do though is to draw our line. And so for my number line, what I like to do is I look at my lower extreme, which is 18, and I want to start at a number less than 18. So I chose 0. And then I wanted to find a number greater than 100, so I decided 110. Now I can place my dots above the number line. So I'm not going to put them on the number line. I'm going to put them above. So there's my 18. It's hard to see exactly, but you can tell it's about 18. Then I have my 52, my 68, my 87, and my 100. The next step is to draw the whiskers. So I drew a whisker from the lower extreme to the lower quartile and the upper quartile to the upper extreme. Now I get to make my box. My box goes through the lower quartile and the upper quartile. And the last step is to draw my line through the median. And that's my box and whisker plot. Now, when we were talking earlier about the box, we said that 50% of the data is in there. And we call this the interquartile range. And in order to figure out how much the interquartile range is, we can take the upper quartile, which is quartile 3, and subtract the lower quartile, which is quartile 1. So in this case, our upper quartile is 87 minus our lower quartile is 52. So the interquartile range, or IQR, is 34. Okay, so now let's look at this. These are the temperatures we were talking about earlier in the video. So we've got some temperatures from different cities in March, and I did not put them in order. So let's first put them in order from least to greatest. There we go. Okay, now we're going to find the median first. So let's find the middle number. Uh-oh, I have an even set of data. There's 10 pieces. So that means that the median has to be somewhere between 15 and 17. So that's okay. We know how to do this. We'll just find the mean. So 15 plus 17 is 32, and divided by 2 is 16. So that means that my median is 16. Now, remember, for the lower quartile, we don't include the median. So I'm looking at all the numbers to the left, but not including the median. 1, 2, 3, 4, 5. Ooh, this is nice. There's an odd number of data sets, so data pieces. So therefore, it'll be easy to find my middle number, which is 12. So 12 is my lower quartile. We'll do the same thing to the right, and 45 is going to be my upper quartile. Lastly, we have our lower extreme. That's our smallest number. So that would be 10. And the upper extreme, which is the warmest temperature, 98. Woo, that's hot. Okay, now that we have all of our circles, 1, 2, 3, 4, 5, we can make our box and whiskers. So here's my number line. Again, I want to start with a number less than 10. I use 0, and greater than 98. I used 100. And let's put our dots. So the first dot is our lower extreme, which is 10. Then our lower quartile, which is 12. Wow, they're really close together. And then our median, 16. Wow, those are close. Our upper quartile, oh, that's a little bit further away. That's at 45. And that upper extreme is way over to the right at 98. Now we're going to draw our whiskers. So the lower extreme to the lower quartile, the upper quartile to the upper extreme, our box that goes through the lower quartile and upper quartile, and our line that goes through the median. Now let's figure out the interquartile range. We're going to subtract the upper quartile and the lower quartile. So upper quartile is 45 minus 12. So the interquartile range is 33. So what does that 33 tell us? Well, the middle spread, or the range of the middle 50% of the data. So it tells us how far apart that middle chunk of data is. So since the IQR is 33, that means that the middle half of the cities had temperatures that were 33 degrees Fahrenheit apart. So now let's see if we have any outliers, because this is looking a little suspicious to me. It's way out there, but I have to make sure that it truly is an outlier. So we can look to see if it's going to be too low of a temperature or too high of a temperature. So in other words, when it's too low, it has to be any value that falls below what we end up when we do this equation or this expression. So we take quartile 1, which is 12, and we subtract the product of our interquartile range in 1.5. So 1.5 multiplied by 33 is 49.5. And 12 minus 49.5 is negative 37.5. So in order to be an outlier, the temperature has to be less than negative 37.5 degrees Fahrenheit. That is super cold. And our lowest one was 10. So that's not even close to it. So that looks fine. But I was actually worried about this one because this one looks pretty hot. So let's do the same thing. But for this one, we're going to use quartile 3 and we're going to add it. So quartile 3 is 45. And we're going to add it to the product of 1.5 and 33 because remember, 33 is our interquartile range. So 45 plus 49.5 is 94.5. So 98 degrees Fahrenheit is an outlier. I thought it might be because it looked like it was way out here. Again, it's greater than 94.5. So what do we need to do? Well, it's not allowed to be in our graph as a dot. So instead, I'm going to put an asterisk because it is a piece of data. So we put the asterisk there. And now I need to find my new upper extreme. So my new upper extreme is the next largest number, which is 62. So now I can put my pink dot at 62 and draw my whisker. And now this is my box and whiskers, and I notice here that I have my outlier. So what does this graph tell you about temperatures? You might want to pause the video here and see if you can come up with some of your own ideas of what this is telling you, and then start it again and see if you agree with what I came up with. You might have found some other things as well. So I saw that 98 degrees Fahrenheit was an outlier, and I noticed that because there was an asterisk. I also noticed that most cities were cold in March. They were between 12 degrees Fahrenheit and 45 degrees Fahrenheit, because again, these are the most cities in our interquartile range, which is 50%. I also noticed that 25% of the cities were 12 degrees Fahrenheit or colder. And I noticed that half of the cities were 16 degrees Fahrenheit or colder, and that 75% of the cities were 45 degrees Fahrenheit or colder. So in March, those cities are cold. I also noticed that the temperatures were spread out, but most of them were on the colder side. So now let's look at this next box and whiskers. And for this one, I'm looking at two sets of data. I'm looking at Nicole and Barry's math scores. And what do you notice? Again, you might want to pause the video and then start it again after you have some of your ideas. So here's what I noticed. When I was looking at Barry's math score, he seemed more consistent since his interquartile range is about 10, where Nicole's is about 15. So Nicole doesn't look as consistent. So 50% of his scores have a range of 10, where Nicole's range is about 15. I also noticed that Barry's scores range from 60 to 90, where Nicole's range all the way from 41 to 99. So even though she's got some really high scores, she also has some really low scores. Again, so she's not as consistent, where Barry is more consistent. But I did notice something that they have in common, and that both of them have a median score of 80. So I thought that was rather interesting. So maybe you saw some other things that you thought was interesting about this one as well. But I wanted you to get an idea of how to make a box and whiskers, because it does look a little confusing at first. But then once you learn how to make the circles and turn them into dots, it's actually pretty easy, and I think it's actually fun. I hope you also understand why we use box and whisker plots and how they can be used to really look at a lot of data and see how things are ordered or arranged. In other words, where you see most of your data. As always, thank you again for watching.